Here in this problem, we need to show that the sum of these three vectors, GA vector, GB vector, and GC vector, it's the zero vector whenever G is the centroid of a triangle ABC. Okay, let's begin. First, we're going to consider a triangle with vertices A, B, and C. Now, for this triangle ABC, ED, BE, and CF are the medians of the triangle. A median is going to bisect the side of a triangle into two equal parts. Now here, G is the common point of intersection of the three medians, and that's also referred to as the centroid. Now our goal will be to show that GA vector, GB vector, so GA vector as a vector going from G to A, GB vector going from G to B, and GC vector going from G to C, the sum of these three vectors equals to the zero vector. Now, we have already worked in a previous problem that the position vector of the centroid of a triangle is given by the sum of the position vectors of A, B, and C, the vertices A, B, and C, divided by 3. So let us first name the position vectors of A, B, and C as A vector, B vector, and C vector respectively. So now we will consider the position vector of the centroid. Position vector of the centroid G, that will be given by OG vector. So that's A vector plus B vector plus C vector, all divided by 3. Fine. So let's now define GA vector. Now what is GA vector? So GA vector will be OA vector, the position vector of the vertex A, minus the position vector of the centroid. So OA vector, that's vector A. So we have A vector minus A vector plus B vector plus C vector divided by 3. So we have 3A vector minus A, that means we get 2A vector minus B vector minus C vector whole divided by 3. Similarly, we can define GB vector. So GB vector will be OB vector minus OG vector. So OB vector, so that's B vector minus the OG vector, that's going to give us 2B vector minus C vector minus A vector whole divided by 3. And then finally we have GC vector. So this will be equals to OC vector minus OG vector, which will be equals to 2C vector minus A vector minus B vector whole divided by 3. Okay, now that we have these three vectors, let's take their sum. So we have GA vector. Now finally we have GA vector added to GB vector plus GC vector. That will be equals to, so we have 2A vector minus B minus C whole divided by 3 added to 2C vector minus A vector minus B vector whole divided by 3 plus 2B vector minus A vector minus C vector whole divided by 3. And when we sum it up, we were going to get the zero vector. So that means we have successfully showed that the sum of GA, GB, and GC, these three vectors, equals the zero vector, hence proved.